All right. Good afternoon, everybody. Okay, so this is going to be a bit of a departure from very technically grounded conversation, and it'll make sense after I give a brief introduction. So I spent the first decade of my career working for NASA JSC, putting in to orbit, all sorts of different programs. Little jetpack that's on the back of the space simplified for EA rescue. It's one of the programs that I ran. But I ended my time at NASA with a 44-degree freedom humanoid robot, Valkyrie. Ultimately, it didn't perform well at the DARPA Robotics Challenge, but it was a fantastic piece of machinery, and it really launched me into the next phase of my career, which was primarily focused in robotics. And so I left NASA JSC, and for the second decade of my career was focused in entrepreneurship and trying to bring together both how do we leverage robotics within terrestrial applications from a business standpoint and helping industries that are generally denied having robotics. And then that morphed into my most recent company, Novium, where we were combining both robotics and spaceflight hardware to do in-space robotics. So this year, after going and spending the last couple of years raising money and trying to get the message out to both DoD, well, let's say all three, DoD and civil and venture capital, it became apparent there was a messaging problem. And so I'm fortunate enough to take the year off, and I've been going across the nation trying to spread a little bit of a message about what the current state of robotics are, what the future is, and what we need to do to get there. This is less of a science fiction conversation and more about like the nuts and bolts of what needs to happen in order for us to get there. So we have this storied $1.8 trillion opportunity that McKinsey put out at the end of 2024. At the beginning of 2025, you saw these reports just on everybody's presentation, but this was primarily used as clickbait to a lot of the investors in order to say, hey, come give me money. But there was no real discussion on how the industry was going to acquire this $1.8 trillion in opportunity. So pause there for a second and let's take a look back in history on what it takes to commercialize an industry. And I like the mining industry. I've done a lot of work with the mining industry, so I started seeing some quick parallels. In the beginning, we had brave men and women going out into the mountains with a pick, an axe, and a pan, and they were extracting ore and bringing it back to exchange that for money. It was a very human-intensive, labor-intensive activity that really wasn't growing as an industry until William Otis started fooling around in his shed and made what they called the steam shovel back then, which we now call an excavator. This innovation really opened the door to the next step in the roadmap to the mining industry. They were able to extract ore and process it at a rate that was unprecedented up to that time. Wouldn't you know that during this transition, there were strikes, there was sabotage, there was all sorts of drama because all the people that were doing it by hand definitely did not want this machine to come and take their job, right? Us in this industry, we hear that quite a bit. But if you think about mining now, you don't actually think about humans going down into a hole. You think more of a symphony of equipment that goes and is doing the job that the humans would have done, but at a rate that could never be accomplished by just doing it the manual labor way. So if you've ever had the opportunity to go to Australia, the BHP is headquartered there, and they have what they call the IROC facility. And it is on the fifth floor, just a massive control center where they operate between 7 and 10 mines remotely from that location. So think about that for later in the presentation. So what lessons can we learn about it, and where is the space industry in this commercialization? Well, we currently put men and women, brave men and women in a balloon, and we stick them outside the space station. We tell them to install batteries, route wires, and repair solar arrays. There's currently a bunch of activity going on to make what we're calling robots, which I'm going to, hopefully by the end of this, convince everybody here to stop calling them robots. We're going to call them equipment. So then now we're going to use this equipment to fulfill all of the dreams that you see on everybody's presentations on how they're going to do whatever it is that their company's going to make money doing. So it's the same process from exploration to commercialization. And once you know, there's still the same kind of strife in this idea from going from human-centric, human-based operations to equipment-based operations. So this idea of the new space industry, it's interesting, right? The little play on words, the great hope here. So for a lot of us that have been in the space industry for a long time, we've dreamt about space being an economic driver, and how can we make this a sustained economy that allows us to deploy what we love so much, robotics. And so when the new space industry came in about 4 or 5 years ago, it was this promise that we were going to be able to make money doing all these different activities. And if the astute observer can look at every one of these pictures, and perhaps I picked them by design for this one thing, but you see that the enabling technology is some sort of robotic equipment, right? Something that will be the enabler for that. So robotics are the equipment that will move the space industry. But where is the money? And this is something that I think shocks a lot of people when you start looking at where are the opportunities. As a side note, so I'm an engineer, so I'm about ready to put me in this classification. Engineers generally make terrible businessmen, right? Because I find something interesting, and then I go and say I can do that, and I start working on that thing, and then I'm at least smart enough to convince myself that that thing other people are going to buy. But where a lot of engineers fall short is that we aren't the normal consumer, and we didn't check with them, right? So we go off and we make technology that generally winds up not being picked up by mainstream consumers. So what's another way to do it? Well, you go figure out where is the money being spent, and you start solving problems in that particular bucket. The space industry is really broken into, money goes into two different areas. We call them stable economies. So the government and commercial. And the way you think about this is an economy is only defined by something that is funded by money that comes from each of our pocketbook, right? So government takes our taxes, it's then spent in space, right? The commercial sector, we all love our phones, our internet, our data, and so we're willing to pay that bill in order for it to go into space. So the very first thing you can see here is there's this large disparity between government and commercial funding. And on the government side, where all the SBIRs are, we all fight tooth and nail and spend a lot of time coming up with responses for a very little market, just a very little market. But over on the commercial side, we had this, I just showed you the great hope of the commercial industry, but it only represents about $6 billion of the overall market. That is meager. And what is that $6 billion? That $6 billion is what was invested from venture capital in 2024. The year before that, it was $18 billion. But the status quo remains that it's the minority in all of these things. But yet an entire industry was mobilized, and a lot of people became very excited about what the new space industry could be. But the one that probably is the area that needs the most innovation and has the strongest customer set is the satellite market. And if you really spend some time looking at this, about half that goes to ground systems. So that's about a $300 billion opportunity to help an industry of real customers. These are the Viasats, these are the Epusats, the Comstars. They have actual real customers, you and me, that pay for data, and they have a need or a desire to want to make more money. So this gives you kind of just a landscape of where is the industry today and where's the money coming from and where could we go start looking. So let's take a step into what is the state of technology in space robotics. So these are some fun numbers. I went and pulled all of the missions, and there's some wonderful papers out there that cover this in great detail, but you sum it all up, there's basically 9 mobility units ever put into orbit. There's about 12 manipulators, and that includes the ones that are sitting on top of some of those mobility units. And there's been one event. Now, this all probably gets indexed by, or these two get indexed by one, because China just had a fantastic event. We don't know if they used an arm. We don't know if it was all done on our pod, but there was possibly, we could index those two. But there's only been Orbital Express that has actually demonstrated dynamic grappling and control of a prepared object. Now the Northrop Grumman test 2 years ago it did have a robot arm on it, and it did grapple something, but it used strictly RPod-based maneuvers, which is why they put the arm out, they locked it all out, and then they jousted the poor Viasat satellite and then called off 14 times before they finally were able to get the right rates and orientation to grapple that satellite. So it does not qualify as dynamic grappling, and they themselves stood up and says, we are not doing dynamic grappling. So we only had one example of the key skill, right? What are the two things that a robot needs to do in space or on the moon? We do dynamic grappling and we do pick and place. Once you have those two skills, you've unlocked the next level and you can do a bunch of mission planning and do a lot of things. So we really only had one real example of successfully doing that. But yet on the slide a little while ago, we're betting the entire farm that there's going to be this arsenal of robotics that enable the next generation of satellites. You can start to see, or not just satellites, but orbital economies. So you can start to see a bit of disparity that exists in what the hope is and what the reality is on technology. So I like these four missions as a good indicator of what is this technology cost, how long does it take, and what type of skills have they demonstrated in orbit. And my favorite, absolute favorite arm is the Canada-2 arm. I've spent a lot of time with MDA. John is a very close friend. And it costs $1.4 billion. What's not written on here is it was appropriated up to over $3 billion worth of effort. It was funded by two governments. Huge effort, 15 years to get done, thousands and thousands of operational hours. I've spent time in mission control, moving this thing around. It's a fantastic robot. It was delivered back in 2001, and it only has ever demonstrated remotely operated free flyer grappling. And then it also does pick and place. So, right, this from a remote standpoint, we have a lot of experience of an object coming to the ISS and then it coming within our workspace, and we pluck that thing out and then we birth it. That's a lot of experience that we have as an industry. Orbital Express, this is the best and saddest mission ever. $100 million, 5 years lead time, 10 operational hours. And it did not fail. They just stopped funding the program. And so they stopped using it. What a sadness to everybody in the room. Delivered in 2004, it actually demonstrated free flyer grappling autonomously and then semi-autonomous to pick and place, where it would be what you and I would expect being in something like Arviz or some other visualizer, where you say go and put it, grab this thing and put the little cursor over, and then it moves it to that location. Click a button that says grapple it. This represents what we're all actually chasing, and it was done back in 2004. Gatai. Now we see a change in paradigm. This company, I mean, I was in the DARPA Robotics Challenge, friends with some of the leadership in Gatai. Big fan of what this company has been able to accomplish. $20 million for two arms, 2 year lead time. They had about 100 hours of operation in 2024. It was a raging success, but in that they hadn't got to do any free flying grappling. It was all just maneuver and placing from one to the other. So they did get pick and place. Fantastic company. MRV RSGS is the next big hopeful. $100 million. Been working on that for 10 years. It came out of the brainchild of Dr. Gordon Russler over at the DARPA. He was two-time DARPA program manager and then moved into NRL. We were expected that to launch in 2026. And I think it's going to go, right? We've had a couple of recent disappointments on, we're going to go, and then we're not. So this one, I think we're actually going to go. And they plan to do autonomous grappling and pick and place as a semi-autonomous. So this would be getting back to the 2004 demonstration, 22 years later. Okay, that's what we got so far. So what's the problem? Where are all the robots? There's a bit of a perception gap. If you were saw me yesterday on the panel, I kind of was giving a sneak peek on this idea. Yeah, it's just a reality of where we are in terrestrial robotics. You've got robots doing backflips off of boxes, and you go talk to a DoD. I went to talk to the SSC, Space Systems Command, talking to one of the lieutenant colonels there, and I was explaining where we are and where we need to be and how we're going to get there. And he starts speaking about Marvel Comics to me. I'm not making that up. That's not a joke. His idea of where robotics are and what is worth the investment of government funds was to accomplish something that currently is on a Marvel Comics movie. That was the first time I walked away and was like, we have a perception problem. We as a community need to fix this. High cost and limited deployment. We just don't have access to space like we need to. We need to have like this fail fast philosophy mentality is currently locked to Earth, and we need to bust past our Earth's atmosphere and get into space. We need to go and put a 1.5, 2 meter arm on some small satellites and go up there and break it. We need to break as many arms as we can. People are talking about going to the moon. How about we just get some more robots into low Earth orbit and break those for a while? And that'll help inform and reduce the risk to the moon. And then the moon will help reduce the risk as we go to Mars. This is a very important part. I talk with DoD people, almost weekly, and they always ask me, what's the biggest roadblock to getting robotics to go mainstream? And I'm like, this right here. If you want to help with anything, start funding small companies to get their robotics into space. Bespoke design and limited testing. We commoditize robotics. Right, we're building everyone the problem. Go and all the bits and pieces, and then they put it together. They got to go through the qualification plan, go through the verification plan. All that hardware is built, purpose built. I got to talk to my motor manufacturer, get them to spend me a brand new motor for this mission. I'm going to do dual wound, all the stuff, right? And then you throw it away. We need to stop doing that. We need to create a modular tool set that allows us to say, this is a actuator of this torque, and I'm going to grab this linkage and I'm going to plug them into each other. And here's a set of end effectors that I can put on there. Terrestrial, we've pretty well figured that out. We need to start as a community figuring out how we do that in space. Human and supply chain bottleneck. I don't know if you've noticed, but the majority of our industry is here, and there's not a whole lot of us. And so finding the people in order to do this is actually really, really quite difficult. We had just a very aggressive hiring program, and you just can't find. And the people that are really good, they know they're really good. So what do? They go start their own company. So you get all these different little space robot companies. Now they're competing with each other, and we don't have there's scraps right now. We don't need to be competing. We need to be collaborating. So here's my we need statements. We need to shift industry focused and investment towards developing versatile in-space tools that can support a wide range of missions and accelerate innovation, right? It's kind of what I spoke to earlier. We need a tool set, and we need to invest in the tool set. We need an affordable, robust, and flexible robotic tool set. So not only do we need to actually spend time and money making the stuff, we need to make it to where it's available to everybody. And I like to use PVC pipe. If you ever done any sprinkler system, you have a 1/4-inch elbow and a 1/4-inch pipe, and you stick them in together, they're always going to fit, right? We need to kind of create that same kind of flexibility within the robotics industry. We need frequent, affordable access to on-orbit testing. This is probably where we would need the government to step in most, is provide us with access to space. ISS National Lab is problematic and then more problematic. The current problem is there's a huge line to get onto ISS National Lab. They will pay for your flight. You bring the hardware, they'll pay for you to get on to ISS. But you have to provide something to these individuals. It's a business plan that shows where robots close as a business plan. But you can't do that yet, right? There is no business plan that closes. So robotics is almost categorically been excluded from ISS National Lab Awards. Now, honorable mention is Gatai. They did get an ISS National Lab Award, mostly because they paid for their entire trip. They didn't get subsidized from ISS. So they paid for their ride. Well, that goes away in 2023, and we already have a list of payloads that want to go to ISS that are no longer going to have a ride. And we're already deprioritized as an industry to get in there. So there needs to be a mechanism, right? We need frequent, affordable access to on-orbit testing. This is an unsolved problem in the mix of all the problems that I think people have brought up over the last couple of days. We need to lower the barrier to operations. So this is one that I get on my soapbox quite frequently. We think of robotics through the interface of a terminal window or through kinematic relations. And if we want it to move, it's through a very isolated user interface, meaning you got to be an expert just to move this robot. We need to move it to things that operators can easily affect the motion of the robotic systems. We are not the operators. We are the race car. We are the race car designers. We're not the race car drivers. We need to get controls in the hands of people who can then take our work and push it to the extremes that we've never even thought of. If you've ever spent any time talking to whether it's a military operator or the operators at JSC, they think about things just a little bit different than we do. We're trying to figure out how to get the kinematics to reach around and get a solution set. They don't care about any of that. And this is the harsh truth here. I think I said it to my friend over earlier, like nobody gives a shit about robots. What they care about is what is it that the robot can do at the end result. It's like being the excavator salesman and saying everybody cares about excavators. Well, no, they only care that the excavator can extract the ore. We need to be more mission oriented, and by doing so, creating the steering wheel, if you will, for the robots, for the operators to use the robots. And then finally, we need to commoditize space robotics. This happens through, by using modularity, now I can get higher quantity levels and get a break in cost. I can stop my repetitive redesign over and over and over every time I'm making a new actuator. I don't need to do it from first principles. Let's start commoditizing some of these capabilities. So I think the demand is clear. We're going into we're ushering into the next phase. Everybody is assuming that robots will be ready when they finally get funding from their investor, diluted or otherwise, to go do a thing, right? They put it on every one of their pictures on how they're going to get it done. So we just went through all the barriers. The demand is robots must become near-term industry priority. We need to invest and focus on low-cost, robust tool set that unlock the next frontier of space commercialization. A couple of companies here that like I said, that I'm a big fan of: MDA, my company Novium, Gatai, and Motive. They're out there trying to make it happen, and I think there's many of us in here doing the same thing. I think I've seen a lot of really cool robots that need just as much support. So what's the next step? We need to focus on deploying technology fundamentals. So I hear a lot about we can only go to the moon if we have fully autonomous systems. We can only interact with a satellite if we have a fully autonomous system. There's this qualifier that seems to go along with robots that needs to be fully autonomous. I take issue with this because it's like saying that we should never have driven cars until they were self-driving. There's this opportunity from when the hardware has capability and full autonomy comes online that you can still do stuff. The underwater robotics industry is a fantastic example of this. They have up to a 7 sleigh time, and they're making billions of dollars a year off those robots. So they're great. They have a cool system where they will move the joystick, lock it in, and then it won't move the joystick until you see it move in real that feed. And now you can say, I'm going to execute my next move. Right? We're repairing BOP valves. We're shutting using remote robotics with latency. There is a path to getting this done. So on orbit logistics, what are some of the things that we need? Rugged hardware, we already talked about. That communication networks, we have fantastic satellites. Workspace mapping, this is that close, but they're we're starting to get some convergence on that. Robotic dynamic grappling, there's a lot of companies that have been funded both by government and private agencies to solve this problem. I feel I have it highlighted. This is the key to our industry right now. Dynamic grappling is a big deal. Robotic pick and place, I think we have handled, and then we need to get into space, right? The stuff we talked about earlier. And then remote operations enables all of this prior to autonomy. So you look at lunar logistics, we have a lot of the same stuff, but we have to add this PNT for lunar comms for the moon. It's hard. We not only, there's Near Space Network that is being stood up. I think Intuitive Machines is currently building their first satellite to go that way. I shouldn't say I think I'm working on that. So it's going to go. It's going to be great. Keep your eyes out for it. Workspace mapping, I think we solve on both sides. We have some of the shadowing problems that I think we were brought up yesterday, but I think we're on the hunt to finishing that, figuring that out. Standardized interfaces, same problem. It all comes down to remote operations, and then autonomy can come in later. My goal in this is to help mostly in the investor class realize we have the majority of the tools to be successful now. We don't need to wait. And now we can go and start doing operations on the moon while the autonomy kicks in later, right? We can drive the cars until the autonomy starts. It becomes an upgrade. And it's an infrastructure that also enables our industry to, okay, I'm going to try this autonomy package or a semi-autonomous package, and it's in situ, and I can get time on that asset and I can deploy it and get instant feedback. So it acts as also a test facility as well. This is a PowerPoint, but normally those are cool videos. So, oh, look at that. They are going to go. I don't know that I'm going to let you go through the whole thing. Let's see. Yeah, it takes too much time. So how does that translate to improving life here on Earth? This idea of remote operations has not only some precedence, but is got some movement in different industries. The aviation industry is an interesting one because we have been flying unmanned aerial vehicles remotely for a while now. And we're trying to figure out how do we cross that bridge with human life? How do we gain the trust of the population to do that? What we'll find is you can't do it with a current player in the market. There will be some new entrance that says, hey, you don't have to fly on our aircraft, but if you do, it's going to be remotely monitored by by a pilot that is monitoring 3 or 4 different aircraft. And then you as a customer get to choose whether or not you want to go in and trust your life. I guarantee as we start to hit these maximums where you aren't able to get flights or you're getting delayed all the time and you're frustrated, that hits some sort of boiling point that you're like, screw it, I'll just go ahead. I'm going to risk it. I'm going to get on this aircraft that has no pilot, that is remotely monitored. The skills you learn there are the same skills you're learning for LEO operations and for lunar operations. Mining industry, they're faced with the same paradigm. They have 2 problems. One of which is it's really hard to get down into a mountain. True. The second one is they're wanting to go deeper where we're hitting human limitations. Like the human body can only go down so far. If you've ever been in a mine, they're miserable. So they're already right off the bat trying to decrease their overall cost on making that environment safe for humans. If they can not have to pump in all the atmosphere and they can leave it as dank as they want to and just send robots in there, that is a huge cost savings for that industry. And then now it enables them to go much, much deeper. So spending time with the Australians in Oak Dam, they're wanting to open up what they're calling entryless mine. And the main challenge for them is getting communications. As it turns out, comms don't like to go through bedrock. So how do you get comm all the way down to wherever they're extracting pay? And the idea is to create a mobile network, kind of like our constellation system, that can move, that will optimize the communication pathway from topside down to their in situ assets so that it can be operated remotely. This remote operation is not there forever, but it is the first step that enables money to be made immediately. So here's my call to action. This is normally, and I'm talking to an investor class, this is really not, it falls on deaf ears, but for this group, this is the main call to action. We need help with perception. We need a little bit more science and a little bit less science fiction. There's a lot of pressure for us to create we get money for however it comes to us, and we get this robot and we're going to do a demo and we try it 15 times and then it finally does it that one time. And that's when we cut the video and we send that out to everybody. And where that feels like what we're doing is getting our best chances of reoccurring funding, we're actually damaging our industry, because everybody that doesn't realize how hard it was to do what you just did consumes that and says, oh, this robot thing's done. I don't need to put any money in that industry. We need to show our failures. We need to help people really understand how difficult it is to do robotics in space. so that they will help and be energized to help that problem. Think about it. You want them to feel that pain because they've got a lot of money wrapped up in the end product being successful. Whatever the picture earlier in the slide was, like I'm going to go do, trash removal. They're putting money in that, thinking that the robots are going to be there for them. They need to realize that money needs to be spent on bringing the robots along. So we need to help with this perception. That is the longest I've ever spent on that bullet. Um, Advocate for investment in scalable, low-cost robotics. I think we all agree on that one. And then this was an interesting one. Unite as a robotics community. Because the funding is so scarce in this area, there's a lot of unnecessary competition. And there's a lot of companies. If I had $1 for every time I advised a company that says, "Oh, I only started this company because I couldn't find the company that does this," I could retire right now because it's funny. Everybody wants to do this and they're looking for each other. But for whatever reason, they feel like they need to go start their own company. And then now what I see, I've got 5 in-space robotics company right now. Each of them have right around $3 to $10 million in venture funding, and they're all the same. It's some software guy that got out of school that can go simulate how to do something in space and has no experience in space, and some guy that knows connections to either DoD or an ex-astronaut or somebody in the investment community. What would happen if those 7 or 5 different groups got together? All that money was shared and all the experience and capability became one company. Right? What would that do to our industry? And that's with 5 of them. There's a lot of really smart people in this industry. We need to start putting collaboration over competition. We need to make robots the industry priority. I think our industry is gonna hit a roadblock here pretty soon. And I think we're already feeling it, right? All this money went into CLD and CLIPS providers and all these big missions, but all the secondary market, which robotics are considered a secondary market, are not receiving any investment money or very, little comparatively. And so now they're like starting to look back and be like, where are you guys? I'm like, we're still trying to get robots into space, fellas. So there's a certain amount of, we need to start raising the flag to everybody that'll listen to us. Like this industry, this particular technology needs support. And that's my spiel. 33 minutes. That was pretty good. 33. Questions, comments, concerns? Great, I nailed it. Oh, man.
So you were ground before I came over to AI space network, right? So talking about the deep space network and the PNT network. So you're talking about, the difference between the latency of 7 seconds, you're talking about.
Yeah, for underwater.
Right. And also you have complete continuous access to your network to talk to it. But the deep space network, if the humans, I'm assuming in this scenario, are still on Earth, right? You've got to get access to the deep space network, then potentially send additional comms and PNT and then continue that. And I feel like I want to give you a counterpoint almost.
Please do, yeah.
Autonomy, I think it's actually really critical because the infrastructure to build additional deep space network are large additions like average $20 million, $35 million, $35 million per dish. And so we're talking about funding, and yes, they're making some different changes to it and stuff, but I feel like the amount of time and money we spend on making autonomously, it's probably going to happen a lot faster than the amount of time it takes to rebuild an entire ground station with large dish antennas that can be remotely and paid for by a robotics company with low investment. Because the cost of taking minutes on a large dish antenna is so high. And how many communications do you need to do, 7-second delay? Wait, again. So, I don't know, that's my counterpoint. So, there's some counter argument. I'd love to hear it.
So, yeah, you're not wrong. All roads lead to getting the industry going, right? So long term, you need to go from remote operations to semi-autonomous to full autonomous, and observed observed autonomy. You get 2.8 seconds latency from right now to the moon and back. I don't have to have additional network. Now I do have a bandwidth problem. So company Laserlight, who's setting up orbital comms for a relay station in L2, L1, I forget. there's going to be in the very near term, we're going to wind up getting a bigger pipeline to send data down. So there is a data message problem. The main thing from the DARPA Robotics Challenge that they were trying to do was reduce comms, reduce data for semi-autonomy. I think you do want to include some semi-autonomous lower level um, capabilities, but the same as like the IROC facility in Australia, they're not over there actually running the controls. They're saying go to this location, and then they hit a waypoint and it goes there, and then it says I'm waiting for my next instruction. So you have kind of this blend of both of them. If you say I'm not going to do anything until I have a fully autonomous robot that can look in situ and make decisions real time, you're going to be waiting for a long time before you can deploy robotic systems. I think there's a lot of stuff you can do now as you work towards that place. And I'm happy to continue the conversation. In fact, part of this whole year has been learning the counterpoints, and it gets folded into the presentation. We're just trying to spread the word that these are the things that need to be done.
So I had a quick question. So one of your slides you mentioned government needs to sort of help, help with a lot of these different policymakers, right? And you mentioned talked a lot about small businesses, but you also said, like for example, there are already solutions to a lot of these issues, right? Or terrestrial solutions. One example is UR3, right? They have modular robotics for industrial automation. So my question is, do you think there should be any effort to encourage existing businesses with already really strong terrestrial solutions to get into the space market? And how?
Oof.
Because like for example, like if I took a UR3 and space qualified it, maybe that's the easier path in funding all these startups or NASA doing it.
It's a good thought. Once again, that is probably the email I get paid the most to answer is why can't I take a UR robot and put it in space? Um, by the time you go through, like you buy this thing, you got to blow it all apart and get all the greases out of it and then put Brice code in it or Crytox and then all the things. By the time you go through the entire, you might as well just have started from scratch. I like the idea of taking an existing company, any existing company that has a revenue base and peeling off a IRAD effort to go and make a space robot. In fact, I'm working on buying um, a motor manufacturing plant right now because it has a fantastic customer pool. And you know what we don't have is anybody that's making space rated motors. So you can peel it off to make a product line specific for an emerging market. I think the terrestrial robotics industry could do the same thing. After talking with a lot of them, though, they almost don't have an appetite because they already have like their hands full with the booming terrestrial market. I mean, all of us are silly. Like we're wanting to try to make money doing robots in space, right? Doing robots here on Earth.
I guess my question to you is that what government funding should be used then? Is to maybe incentivize them to get into the market somehow?
If you want to give the money to them to pivot their industry, that's going to be a big price tag compared to investing in a small company that doesn't have any um, pre-existing assets. You almost spend less. That's how you leapfrog an established large organization is with a startup company. This is the whole precedence for why VCs put money in startup companies and not existing companies, is that they have less baggage to do that step change. If you wanted to, you would like. I don't think that that's the appropriate use of government money. That's my opinion. I think that's appropriate use of that company's IRAD funds. The IRAD fund for smaller companies is generally government or VC. The reality is, um, like, so we're about ready, something that's not in there. I'm writing an op-ed on orbital threats. And what you're finding is the DoD is is just clueless with how to focus its funding in order to deploy robotics. Well, a lot of technology, but specifically robotics. They they have the money. They have had the process specifically during World War II. How did we create the aviation industry, right? Is that the DoD said, hey, you're going to be an integrator, you're going to do radios, you're going to do fuselages. Nobody had a choice, and they put it all together. And then at the end of World War II, what was left in its place is the aviation industry. We would not be flying on planes like we do today had World War II not happened. Going into war ready by 2027, the DoD is starting to learn like what is our responsibility for collecting an existing bespoke industry and aligning them in a way to produce the assets we need. And the one thing that is becoming blatantly clear is that the main asset that the DoD will need is going to be robotic systems. They just haven't fully crossed over that, and it won't be on lunar applications right away. It's going to all be in orbit assets.